Okay, great. So yeah, I'm Frank Macreery, and I'm CTO of Aptible. And today, I'm going to talk about how we use containers at Aptible to achieve our security and compliance objectives. So a little bit about us, Aptible. We're a platform as a service built for HIPAA compliance. And so that means that we provide a deployment platform that works kind of like Heroku, Deis, or Flynn, but with a focus on standardizing, documenting, and auditing the way that our customers' apps and databases are deployed so that they can maintain HIPAA compliance. So I'm going to start here with a brief overview of HIPAA. It's going to be brief, I promise. So first off, what is HIPAA? Who here knows what HIPAA is? Who here has had to deal with HIPAA in a software application? Okay, great. A lot of people. So HIPAA has to do with hippos, obviously, right?
I wish.
Yeah, unfortunately not. It's a common misconception, though. HIPAA has to do with protected health information, or PHI. So PHI is data that's created by a healthcare provider, which is like your doctor or hospital, or a health plan, so your insurance company. It relates to your health or your mental or physical condition, how you are cared for, so how care is provided to you, or how you pay for care. And most importantly, it identifies you as an individual. So HIPAA regulates how the privacy and security of this type of data, PHI, needs to be maintained. Okay, so who does HIPAA affect? Who's regulated by it? Who cares? First off, we have covered entities. So these are the health plans, insurance companies, healthcare clearinghouses, which are brokers that basically process insurance records, and healthcare providers, who are your doctors and hospitals. These are the primary entities that HIPAA was intended to cover. There's also a class of companies called business associates, which are companies that create, receive, transmit, or maintain PHI on behalf of a covered entity. So in terms of software applications, these can include companies like ZocDoc that help you book appointments online with your doctor, or Zenefits that help you obtain health insurance. They also include companies like Omada that connect you directly with a healthcare professional. They include tools like Doximity and Flatiron Health that are platforms for doctors and medical researchers. But they also include all of the infrastructure providers that these companies use. So Google Cloud Platform, AWS, Azure, Rackspace. And lastly, with the rise of health and wellness apps and frameworks like HealthKit, any app that shares your data with a doctor or insurance company is also a business associate. And importantly, so as of 2013, the law changed. So HIPAA had a new version, the Omnibus Final Rule, and all of those business associates are now also regulated by HIPAA. So it's not just something that doctors and health insurance companies have to deal with anymore. Okay, so all that's great. But why do we actually care about HIPAA? Why bother complying? There is a stick and a carrot as the reason for this. So the stick is the Office of Civil Rights. So this is the enforcement agency that conducts audits periodically and randomly to make sure that regulated companies are compliant. Between 2011 and 2014, in those 4 years, 115 audits were conducted. But by HHS's estimate, there's somewhere between 200,000 and 400,000 business associates. So the likelihood of getting audited as a software company that's regulated are extremely low. However, if you're doing business with a hospital or a health insurance company, it's almost certain that they're going to conduct a vendor assessment which is based on HIPAA and very similar. Okay, so now that we've gotten the basics of HIPAA out of the way, what do we have to do as software developers to maintain HIPAA compliance? A lot of it has to do with common best practices for information security. But one major piece that may be new to software engineers who've worked with security in general is auditing. So not only do you have to implement security, but you have to document what you've done and audit it on a regular basis. In particular, you need to document your response and how you've mitigated every vulnerability that you face. So who here in this room has dealt with or had to deal with a security vulnerability in the past year? Okay, I see some hands. Who here uses OpenSSL anywhere in their stack? Okay, all of you guys should have had to deal with a security vulnerability or a few in the last year. So just to recap, in the past year we had Heartbleed, of course. Then we had Poodle Bleed. And at some point in the future, we're going to have some other bleed that we don't even know about yet. It's certain. So with any of these vulnerabilities, how can we prove that PHI that's being transmitted and encrypted using OpenSSL was unaffected by that vulnerability? The way we do it at Aptible is to document every single security response with a new integration test. And I'm going to walk you through an example which uses our NGINX container image. And so, NGINX is pretty crucial here because it's deployed everywhere throughout our infrastructure, and it's responsible for terminating SSL and encrypting data in transit using OpenSSL. So to write our integration test, we use a suite called BATS, which is really simple. You write your tests as bash functions, and if they exit 0, they pass. It's a passing test. One thing that we do, which may be somewhat unique, is that we actually run our integration tests as part of our image build. So you can see we've got a test directory full of BATS test files in our Git repo that's tied to the Docker image, the container image. And we add that into our image, and then we run BATS on that entire directory of files. Here's an example of one such integration test. And so this was one of our responses to Heartbleed. So first, we install a Heartbleed checker. So this is Philosatiles Heartbleed checker. Then we spin up NGINX and wait for it to respond to requests. And finally, we run the Heartbleed check on port 443. So one of the really nice things about this framework just being built on bash functions is we can extract shared behaviors like installing Heartbleed into their own bash function. And so basically, we just need to download and install the Go package, and then we can have a corresponding uninstall Heartbleed function that cleans up everything after the tests are done. So we get back to a container image that is concise and only contains what we need at runtime. So here's a couple more example tests just to illustrate this process. So these ones are for Poodle, and specifically they're documenting and testing that our use of TLS fallback SCSV is properly implemented, since we have many clients that are still using SSL v3. So first we just check that the extension is installed, and then we check that it is enabled by default whenever we don't have TLS. Okay, so like I mentioned, these integration tests run during every image build. And that comes with a few great benefits from an auditing perspective. First, these images built automatically via Quay.io build triggers. So every time we merge into master on the corresponding GitHub repo, we get a build and all of our integration tests run on Quay. And because of Quay.io's excellent build logging, we have a permanent historical record of the logs from this build. And so in particular, that includes all the steps from these BATS tests. And it shows that they all passed and that we were, in fact, testing for our mitigation of Heartbleed. So you can see it says it should pass an external Heartbleed test OK. One other advantage is that the build status is easy to verify at a glance. So when I log into Quay.io, this is a subset of what I see. So we've got our container images here, and we've got a build status associated with each. So if the status is green, I know that the image is built successfully and that all of the tests are passing. And if it's red, like it is for MySQL up here, I can examine that build specifically, and either the tests are failing or there's something else wrong with the build. But it's pretty easy to isolate. And then finally, with the new Quay.io time machine that was announced by the Quay guys yesterday, we can roll back to an image at any previous state, which is exceptionally useful for auditing purposes. So we can basically go back to the point in time at which a vulnerability occurred, examine the tag, the hash of the image that we were using at that time, and then roll back to it. And we can look at the container image and either determine A, that we were already testing for the vulnerability at that time and had a mitigation in place, or we can run a new container based on that image and test that it passes and is not susceptible to the vulnerability. So that's one way that we use containers and Quay.io specifically to achieve our auditing goals. We also use containers to implement real security safeguards, and we do so largely through standardization, which I'll explain now. Okay, so one more brief HIPAA-related aside to establish some context. So at the beginning of the talk, I mentioned business associates. So every business associate relationship comes with a contract, and this is necessary for every chain of business associates and the companies that they provide a service to. So for example, each of our customers has a BAA with every hospital and insurance company they work with. They've got a BAA with us then, and we in turn have a BAA with Amazon as our infrastructure provider. And each one of these contracts lays out some ground rules that you need to follow in addition to the bare minimum of HIPAA. So with AWS, this comes in the form of approved services. Okay, so quick contest here. And people who already, well, you know who you are. So who can identify what services each of these icons correspond to? Each one is an AWS service, and I will buy you a drink if you can get all 6. Does anyone think they know? Does anyone want to give a shot? I got someone in the back. All right, go for it. Okay, EC2, elastic load balancing, great. That's great. Yes? Yeah, that's really good. I'm very... Redshifts, the last one. What's the second to last? Well, I'll get you a drink anyway, because that's way more impressive than I thought. It's EC2, ELB, EBS, S3, Glacier, and Redshift. So the great thing is that you can use all of these services and be HIPAA compliant on AWS. But the catch is that you have to play by their rules, which include, for EC2, you need to use dedicated instances wherever you're storing or handling PHI. And that's not so much a technical or engineering hurdle as a cost prohibitive one, since you have to pay $2 per hour for every region where you have dedicated instances. So that's about $1,400 a month. You have to encrypt all data that's stored on EBS, either using encrypted EBS volumes, file system level encryption, or some other mechanism. That's pretty straightforward. With elastic load balancing, you have this interesting problem that you need to use TCP mode only load balancers. So specifically, you can't terminate SSL at the load balancer. So this introduces some interesting technical problems. And so to explain this, I'm going to walk through this architecture diagram of how we set up routing for each one of our customers' applications. So in this example, we've got a customer Rails app that has, it's scaled to 6 containers and deployed across 2 EC2 instances. So at the outside, we've got an elastic load balancer listening on 80 and 443 and open to the outside world that is accepting incoming requests. It then routes that to the NGINX proxy that's running on each instance, and then the NGINX proxy routes to the app containers running on that instance over the local loopback device, so over localhost. And to comply with the requirement in Amazon's BAA, the communication between the ELB and the NGINX proxies is plain TCP, and it must be encrypted. So this introduces a bit of a technical problem. which is that since we don't have HTTP, we lose all of our HTTP forwarding headers. So in particular, we lose X forwarded 4. And as a result, our application only sees the ELB addresses. So this is an example of the app logs. And as you can see, it's only getting the internal IP address of the instance underlying the ELB that's on the same internal VPC. So our app can't differentiate two requests as coming from different clients based on IP alone, and it can't do advanced stuff like geocoding based on IP and stuff like that. The good news is that there is a solution here. It's called PROXY Protocol. So this is a standard that HAProxy came up with for adding routing headers to TCP messages. And it's pretty simple. It just prefixes a TCP message with a single line that specifies the originating source IP address and the ultimate destination IP address for each message. And then it follows with the actual TCP message, which might be an encrypted HTTPS request. So this is great, but we're left with the problem of how do we configure our NGINX app container to respond variably to HTTP or proxy protocol requests, since the two are incompatible. So if we've got an NGINX server listening for HTTPS requests and it sees that initial prefix header, it'll interpret it as a bad request and it won't work. So the way that we do this at Aptible is via environment variables. So specifically, we check to see if proxy protocol is set to true in the environment. And if so, we listen using proxy protocol and we set the IP from all clients. And that basically sets the X forwarded 4 header. If we don't have that environment variable set to true, we just listen on port 80 using the default protocol of HTTP. So we use environment for proxy protocol. We also use it for things like force SSL, which is a Boolean, the max age value for our HSTS, the high security headers. We take a list of upstream servers, just a comma separated list of hosts and ports that this container is supposed to proxy requests to. There's a few advantages we see to configuration via environment. One is that it makes testing easier. So as you might guess, we use bats to test functionality too. So when we want to test that our proxy protocol implementation is working, we can simply set that environment variable in the test, in that particular test. And if we're testing something else in a different test that requires just HTTP, we can set proxy protocol equals false. Another nice thing is that it abstracts away the implementation details. So functionally, this container image that we've got is just an SSL terminating container. And it could be anything. It could be NGINX, HAProxy, Apache. And so long as we respect these environment variables that correspond to a few features, we can swap out the underlying implementation, and our customers' app containers wouldn't care. And we could deploy it across our entire fleet. A third reason why we like environment-based configuration is that we don't need to know all of the parameters in advance. So this is related to what Brendan Burns talked about yesterday in his Kubernetes talk about key value tags being better than hierarchical representations. And it applies here too. We can add keys as we go, and we don't need to know in advance the entire hierarchy of all the functionality that we're going to support. So obviously, now that we've come up with this standard for how our SSL terminating proxy container should work, we want to move on to standardizing other things. And so one other thing that we standardize at Aptible is our database container images. So to give you an idea, databases on Aptible are managed by us. We have our own container images for them. They're all open source, but a customer will request a specific database technology like Postgres or MongoDB with certain configuration and capacity requirements, and then we will provision and manage and monitor it. So one area where we like to have standardization is in how we initialize the data directories for each of these databases. And so every database that runs on Aptible, every app container takes a -- initialize argument, and that will set up the initial data directory with an empty database, regardless of the technology. So basically, every single database we support has a run database script in the image, and we set that as the entry point of the image. And then, so this example, this is our initialize script, or sorry, this is the run database script for our Postgres image. We're able to check for whether we've got the initialize argument, and if so, we do a bunch of steps to set up the database and initialize the data directory. And if we don't have that argument, then we just go ahead and we start the database. Another thing that we can standardize is authentication. So every database container image takes a passphrase environment variable. And if this is present, for example, in Postgres, we create a database user with that passphrase. And it's the same environment variable for Mongo, Postgres, Redis, whatever. And then finally, we can standardize how we perform encryption. The way we do this is that we use the image metadata, and specifically how volumes are defined on the image, to specify where PHI might be stored inside a container. So the one requirement that we have in our images, in the Docker files we use to build them, is that we include a volume instruction to specify each directory in which a database might store its data. And then on the back end, when we launch a container off of this Postgres image, we can look at the metadata, figure out the volume bindings, and mount each one of those directories on an encrypted file system in the host. Additionally, we set up continuous automatic backups of that directory that, again, the data backups are encrypted and uploaded to S3, all because we know where data is going to be stored by this common specification of every volume in the image is a possible place for data to be stored. This also makes it easier for our customers to submit their own database images. So if their image if it fits with this specification, we can deploy it and we can manage all of these security functions for them. So just to recap, using containers and building them on Quay.io helps us with auditing because we can automate and document our incident response. Using containers helps us standardize and abstract common functionality like SSL termination for security processes like encryption in transit. And using containers also gives us a way to standardize encryption at rest by specifying all of the volumes where encrypted or where PHI might be stored that we need to encrypt and back up. So thank you. That's all I've got. And I think we've got about 5 minutes for questions if anyone has questions about anything related to containers, HIPAA, whatever. Okay.
Have you guys spent any time considering whether or not you might want to specifically isolate the systems that have PHI from the systems that don't have PHI, so there are fewer restrictions or for some?
Absolutely, yeah. So the question is, have we thought about separating the systems that contain PHI from systems that might not contain PHI? So we do this in a couple ways. So within an environment, so like, an example customer might have a development and a production environment. In their production environment, they've got applications which are ephemeral that are simply taking requests. They're doing encryption in transit, but they're not storing PHI. And then they've got databases that are actually storing them on disk. So these live on separate subnets that correspond to like different layers in our orchestration system. And so like their database containers are always on a separate set of instances on a separate subnet than their apps. And similarly, like across environments, so their development containers are on a completely separate VPC from their production containers. So I'm not sure if that answers the question, but yeah, so part of it is at the container level, but part of it is at the entire orchestration level.
And what benefits have you seen from doing that? What was the reasoning, basically?
Yeah, so the question is, what was the reasoning behind that? And I mean, so it allows us to have differential security requirements on each layer. And so since it's a completely separate set of, like it's a separate subnet, separate instances, we have different security group rules. And so, I mean, it's beneficial in that we can have like different intrusion detection rules on the data layer. I mean, in practice, we haven't had a breach, so I don't know if there's like a practical benefit, but just from it, administering the systems, it makes it a lot easier to know and be confident that everything has the right security settings. Oh, okay. The question is, how do you manage your keys? And so we started this before KMS existed. And so the keys, we basically, part of our PASS API includes a configuration management system where we encrypt and back up the keys. And so all configuration goes through that API, so it's self-managed. If you're rolling this yourself on AWS right now, I think that KMS is a good solution. There's like durable hardware key management stores, which you can use. You can actually run them on providers like Amazon. But KMS seems like a good compromise of cost and efficacy.
What are you guys using for log management?
Yeah, great question. So the question is, what are you using for log management? And so for basically, it's built on top of Logstash. And so every container that gets spun up as part of the orchestration process, you've got the actual app containers, you've got proxy containers, which are like the NGINX proxies, and then you've got log forwarding containers, which basically attach to the logs coming out of the container and forward them on to a common Logstash instance for that environment. And then basically our customers, it's kind of like the outputs configuration for Logstash. We have like a thin layer that simplifies it, where they can use like a syslog TLS output or an Elasticsearch output to have like an ELK stack with Kibana. But that's all. It's basically just they get to configure the outputs that these go to. And then we use a combination of Logstash forwarder and Logstash base to route those. Yeah, that's a good question. So the question is, how do we manage rotating SSH keys? And so for logging into the instances ourselves as Aptible administrators, so we're built on top of OpsWorks, and we tie all SSH user identities to IAM. And we use this kind of cron-based approach where we disallow all of the users. So this is part of the OpsWorks API. You can allow and disallow IAM users to SSH into instances, and we every hour disallow everybody. So you have to explicitly request access in order to grant or in order to log in via SSH. And right now we just have a company policy for updating those SSH keys periodically. I don't think that's enforceable by OpsWorks yet, but that would be a really nice feature. I think that's it. So thanks so much, guys. If you have any other questions, just I'm Fancy Remarker on the web or frank@aptible.com. And thanks so much.